Let's finish lesson 6.6 with solving logarithmic equations. When we're asked to solve logarithmic equations, the problems we'll see today differ slightly from what we've seen in the past. You may have more than one logarithm, and you may have logarithms on both sides of your equation. Just like yesterday with exponentials, a logarithm on each side is true in an equation as long as what you're taking the logarithm of is the same. Unlike yesterday, though, we don't have to change our logarithm bases to make this happen. They'll already be the same in the equation. That means we just have to set one side equal to the other and solve for x. You may need to use properties to condense, and we may need to convert by looping to exponential. What we have to recognize here is that when we solve logarithmic equations, not all logarithms are valid. We'll have to check for extraneous solutions, meaning when we plug our value for x back in, we can't take the log or ln of a negative number. Let's put that to the test and solve A, B, C, and D. In example A, it says solve each equation, be sure to check for extraneous solutions. Log base 4 of 2x plus 6 is equal to log base 4 of 14. Notice the logarithm is the same on each side with a matching base. This equation is true only if 2x plus 6 on the left is equal to 14 on the right. We're not technically canceling the logarithm out, but we're just pulling out the part of the equation we need in order to solve for x. From here, move 6 over and divide by 2. We'll get x equals 4. To check that, we simply plug it back in where x is in our equation. We have log base 4, and then in parentheses, 2 times x plus 6. That means 2 times 4 plus 6. Well, 2 times 4 is 8. 8 plus 6 is 14. Log base 4 of 14 would be a valid logarithm. Also, it equals log base 4 of 14 on the right. This means x equals 4 is a valid solution. Over on the right, with ln, we do the same thing. ln x squared minus 16 is equal to ln of 6x. The ln on the left and the ln on the right are both base e. That means they match. Therefore, this equation is true only if x squared minus 16 is equal to 6x. On this one, we end up with a quadratic equation. That means we have to remember our quadratic rules when solving. Solving a quadratic means we set it equal to 0, and then we either factor or apply quadratic formula. This one factors nicely for us, though, so let's move that 6x over and set it equal to 0 first. We get x squared minus 6x minus 16 equals 0. Think of two numbers that multiply to get negative 16, but also add to get negative 6. We should get negative 8 and positive 2. This would factor then to x minus 8 times x plus 2. Splitting them apart separately and solving, if x minus 8 were to equal 0, x would equal 8 as a possible solution. If x plus 2 equals 0, then x would equal negative 2. Once we get our solutions, we have to check them. If we plug in 8 for our ln, we would have ln 8 squared minus 16. Well, 8 squared is 64 minus 16 would be ln 48. 48 is a positive value. We're in good shape there. On the right, if we take ln of 6 times 8, we also get 48. So we have a match. X equals 8 is a valid solution. But watch what happens when we check negative 2. If we plug in ln of negative 2 squared minus 16, negative 2 squared is 4, and 4 minus 16 is negative 12. We end up with ln negative 12 on the left. And if you try typing in ln of negative 12 on your calculator, we'll get no solution. We can't take the log or ln of a negative value. Therefore, x equals negative 2 is extraneous. All right, you guys try example C. Log base 7 of 4x plus 5 is equal to log base 7 of x squared. Apply that property up above where if the logarithms have matching bases, we just set the parts we're taking the logarithms of equal to each other. Solve for x and check your answer for extraneous solutions. Once you feel you're ready, press play and we'll see how it went. How many of you got that both solutions actually work? I recognize that if log base 7 of 4x plus 5 equals log base 7 of x squared, that's true as long as 4x plus 5 equals x squared. Now what I did on this one is I moved the 4x and the 5 to the right-hand side, keeping x squared positive. That will make your quadratic function factor into x minus 5 and x plus 1. That means x is 5 and negative 1 would be our possible solutions. Plugging in 5 on the left-hand side would give you log base 7 of 25, which is positive. And if we plug in 5 on the right, we also get positive. They're both log base 725. Now be careful when you plug in negative 1. Just because x is negative doesn't mean the logarithm becomes negative. If I plug in negative 1 on the left, I get log base 7 of negative 4 plus 5, which is technically positive 1. And if I plug in negative 1 on the right and square it, we also get positive 1. This is an example where both solutions are valid for the equation. Now our final example, log base 2 of x plus log base 2 of x plus 3 equals 2. Notice this one is different because the two logarithms are on the same side. Now if you're thinking to yourself, well, why don't we just move that one over? That won't work because of the 2 on the right-hand side. What we need to do here is condense the addition. And we condense addition by multiplying what we're taking the logarithms of together. So we're going to start by condensing. We would do log base 2 of x times x minus 3 equals 2 on the right. Now on that left-hand side, I'm going to distribute the x in, and we do end up with a quadratic. Log base 2 of x squared minus 3x equals 2 on the right. From here, we're now going to have to convert to exponential. I'm going to start with my base of 2, and I'm going to loop it. I'll raise it to the second power, and that will equal x squared minus 3x. On the left, 2 squared is 4, equals x squared minus 3x. And now it's quadratic again. I'm going to move 4 over, and then hopefully this factors. 0 equals x squared minus 3x minus 4. This will factor into, what, x minus 4x plus 1? I think that works. And our two choices for x would be positive 4 or negative 1. Now, if we check both of those, I'm going to give myself a little bit more room here to make that happen. Zoom this out just a little bit. If we plug in 4 first, we would have log base 2 of 4 plus log base 2 of 4 minus 3, which is 1. So log base 2 of 4 plus log base 2 of 1. Those are both positive. That checks. If we try negative 1, however, watch what happens. We would right away have log base 2 of negative 1. And that we can't evaluate. That means negative 1 is extraneous and 4 is our only solution. I recommend you review both days of notes before you start your Pearson assignment. And there you go.